Hi there, this is Jihad Homicide, a chemistry instructor. Welcome back to a new recording in AP Chemistry. In today's session, I'll be talking about the mass percentage composition of elements in a compound, and we'll be calculating the empirical formula with the molecular formula of compounds in Unit 1. Let us start by the mass percent composition, guys. The mass percent composition, it talks about how to find the percentage by mass of an element in a compound. It quantifies the proportion by mass of each element within the compound, guys. You know that in chemistry, a compound made up of two or more than two elements, and those elements, they exist with different proportions in a compound. How to know each element individually exists in which proportion in a compound, we will be using this formula to calculate the percentage composition of individual elements. Simply, we'll be dividing the mass of the element for 1 mole of a compound by the molar mass of the compound multiplied by 100, guys. Usually the mass of the elements are the molar mass of the element in the compound, because whenever we have 1 mole of a compound, the mass and the molar mass becomes equal. How to perform the calculation, guys? We should follow 3 steps. The first step, we should calculate the molar mass of the compound from the elements, and then we will be calculating the mass of each element, and then perform the calculations by using the formula which we have provided. Let us solve this example. It's a sample problem. Here we have got the glucose made up of 3 elements: carbon, hydrogen, and oxygen. First, let us calculate the molar mass of the compound, total molar mass, and then we'll be calculating the mass of the elements, and then perform the calculations. Guys, you know that to calculate the molar mass of a compound, we should multiply the molar mass of one atom of those elements by the number of the subscripts, or the number of those atoms in the compound. So the molar mass of carbon is 12, hydrogen is 1, and oxygen is 16. How to calculate the molar mass of the C6H12 or 6? By multiplying the molar mass of one atom of those elements by the subscripts, the number of those atoms in that compound. So here we multiply the 12 of the carbon by 6, and then the 1 gram per mole of hydrogen by 12, and then 16 of oxygen by 6. We got these molar masses of individual atoms. When we sum them, the summation of all, we will get the total molar mass, which is 180.18 grams per mole. Guys, it's time to perform the calculation. We calculated the molar mass of the individual atoms. As I told you, we will be calculating the mass of 1 mole of the compound. So the mass and the molar mass of those atoms are the same. So here the mass of carbon is 72, divided by the molar mass and multiply by 100. We got this percentage, and then we perform the same for the hydrogen and oxygen. We got these percentages. These percentages, they represent the percentage composition of those elements, of those atoms in the compound, which is glucose. If you want to show the this procedure by providing a data table, here we have provided the elements and then the mass in 1 mole of those elements, individual masses, and then we divide these masses by the molar mass, and then we multiplied by the 100. We got the percentage composition of the elements. If you want to show that the procedure by the graphically visualization processes, here we represent the vertically we represents the atoms, and then horizontally the horizontal line represents the composition of those atoms. Carbon is 39.99%, and then hydrogen is 6.73%, and oxygen, you can see it's 53.28%. If it asks about the which one has the greatest percentage, of course oxygen, and then the hydrogen is the least composition in the glucose. Let us talk about how to what's the empirical formula and how to find the empirical formula for the compounds, guys. Empirical formula in chemistry, it refers to the simplest mole ratios, or the simplest whole number ratios of the atoms in the compound, guys. Whenever we have got a compound that has a molecular formula as the C6H12O6, we will be able to find a factor that divides the subscripts by. Here we got the factor common in between all of the atoms, 2, and then we divide by 2. When we divide the carbon by 2, we got C1H2O1. So in this procedure, we have calculated the empirical formula from the molecular formula by simplifying the molecular formula. As you can see here, C6H12O6 represent the molecular formula, but CH2O represent the empirical formula. What's the importance of the empirical formula, guys? It allows the chemists to understand the composition and properties of compounds, and it serves as a foundation for stoichiometry and helps chemists predict the ratio of elements in a chemical reactions, guys. How to calculate or find the empirical formula from the percentage compositions. Guys, first of all, when the percentages are given for 100 grams of a sample. So, and then we'll be converting those grams into the mole by using the molar masses here, by using the molar mass. Because you know that the only conversion factor between the mass to mole to mass is the molar mass. And then we will be dividing the results by the smallest mole, and then we will be calculating the coefficients, or the subscripts, we can say, not the coefficient, of individual atoms. Let us solve this worked example, guys. The question states that the compound made up of 40% carbon, 6.7% hydrogen, and then 53.3% oxygen, guys. Determine its empirical formula. These percentages are masses, guys. So we have 40 grams of carbon, 6.7 grams of hydrogen, and 53.3 grams of oxygen. We will be converting these masses into the mole by dividing to the molar masses. As you can see here, we have got the molar masses. 40 divided by 12, we got 3.3. 6.7 divided by 1.001, it's 6.65, and then 53.3 divided by 16, we've got 3.33. As you can see, the results of carbon and hydrogen are the same, and then they're smaller than the hydrogen. So we will be dividing these results by the smallest, which is 3.3. So we divided for the carbon 3.33 by 3.33, we got 1, and then for the hydrogen we got 2, 1.99, but by rounding we got 2, and then 3.33 of the oxygen we got 1. These results, guys, they represent the subscripts of those elements. So we can say that the subscript of carbon is 1, and then the hydrogen is 2, and then oxygen is 1. This is the empirical formula of that compound. In this part, we will be calculating the molecular formula from the empirical formula, guys. First of all, we should define what's the molecular formula. Usually, the molecular formula represents the actual number of atoms of an element present in a single molecule of the compound, guys. The difference between molecular formula and empirical formula is what? They have got the same structure, the same composition, but with different number of the atoms in the compound. The molecular formula and empirical formula, they can be either the same or we will be multiplying the empirical formula by a number which we call as n. We will be providing an equation later how to calculate the n. How to use the empirical formula to calculate the molecular formula, guys? By using this equation which we have stated here. The molecular formula equals the empirical formula, which should be given in the question, multiplied by n. N is the whole number which we should find through another equation. The steps should be followed. Are three steps, guys. First of all, we should calculate the empirical formula mass, the molar mass of the empirical formula, which should be given in the question, the formula of the empirical formula, and then determine the whole number multiple by this equation, guys. This is the equation to calculate the n. N is should be calculated from what? The molar mass of the molecular formula. This molar mass represents the molecular formula molar mass, and divide by the empirical formula mass, the empirical formula mass which we have calculated in step 1. And then when we perform this calculation, we will be calculating n and then multiply the n to the empirical formula. You will get the molecular formula. Let us solve this question, guys. Here we have got a question said the empirical formula which is given, and then the molar mass of the molecular formula is given. It says determine the molecular formula. First of all, we should calculate the molar mass or empirical formula mass for the empirical formula. How many carbons do we have? 1 carbon, 2 hydrogens with 1 oxygen, guys. So we calculated based on the molar masses of the individual atoms. For carbon is 12 multiplied by 1, we'll get 12. Hydrogen 2.02, and then oxygen 16. Totally we'll get the empirical formula mass. We calculated EFM as 30.0 grams per mole. And then in the question, guys, as you can see, the molar mass of the molecular formula is given. So let us calculate n. N is equal to what? Molar mass, which is given in the question, divided by the empirical formula mass, which we have calculated in step 1. So we got the n is equal to 6. When we have CH2O should be multiplied by 6 to get what? To get the molecular formula. So 6 multiplied by 1 will get C6. 6 multiplied by 2 will get H12. 6 multiplied by 1 we got the HO6. That's how we multiply the n by the empirical formula to calculate the molecular formula. Guys, the summary of this session, it's about how to calculate the mass percent composition. We summarize it in this slide. The mass percent composition of an element can be calculated through the mass of the sample of those elements divided by the molar mass of the compound, and then multiply by 100. You'll be able to calculate the mass or percent of individual elements. Empirical formula, it's simple also. Empirical formula represents the smallest ratio of the combination of atoms in a compound, and the simplest form of a compound represents by the empirical formula. And we solved the question how to calculate the empirical formula. And then finally the molecular formula calculations by using the empirical formula multiplied by n, which is a factor should be calculated from the molar mass of the molecular formula and then empirical formula mass we have calculated. Remember that mastering this calculation skills is crucial for understanding chemical reactions and the properties of compounds in AP chemistry. You should solve and then practice, which is the practice is a key to be professional in a specific topic. Thank you for the attention, guys.